Ritvik, can you hear me?
Hello.
Oh, how are you?
Hi, how are you?
Took a while for it to go through, huh? Okay, so what have you done? Did you do the 1994?
Yeah, I finished 1994 and I did a chemistry Olympiad.
Oh, okay. Which one did you do? Which chemistry Olympiad did you do?
2009.
Chem Olympiad 2009. So, the local exam, right?
Yep.
It's not. So site cannot be reached.
Hmm. Do you need the link again?
I have the link. Olympiad exams. Olympiad. Okay, now it's okay. Got it. I think there was just a glitch.
Okay.
So I have to tell you something.
What?
So I think I have a Valentine now.
Yay. Did you go anywhere with them?
No, he's actually not here.
Oh.
He is coming in March.
Oh, is he also a dentist?
He is. He's actually 5 years ahead of me.
Oh, wow.
Yeah. And it's funny how it all kind of unraveled.
He's already done with dental school and everything then?
Yeah, so he's been practicing for about three years, and he just went back to school for residency. But yeah, that's where we're at. It was funny because I was like, I don't know.
That
I,
could have been a
I don't
perfect
know where
time.
this is headed. But yeah, yesterday we were talking. Actually, he kind of, I think he asked me out like earlier last week over the phone. He said, "Oh yeah, I'm coming in town and I want to like hang out with you." And I was like, "Okay." It didn't really hit me until after I hung up. I was like, "Wait, is he asking me out, or is he like just saying like he wants to hang out?" Like I'm not sure. Like like I don't know. He was being very
Yeah.
shy about it.
Yeah.
And then we were talking, and then yesterday I told him, so my friends and I were doing a potluck. No one is supposed to know.
Sorry, my Wi-Fi cut out at like the climax. Could you say that
Oh,
again?
at the climax.
Yeah,
So my friends and I are doing this.
a potluck.
Yeah,
Oh,
but I don't want to say it loudly because I have a roommate. Um, yeah, because if anyone finds out at school, we will get quarantined.
wow.
We will be pulled out of clinic. Yeah. So I was telling him yesterday, I was like, "Hey, I have to go cook," and he's like, "For what? You don't cook." So I told him, I was like, "Keep it a secret. No one's supposed to know." And he's like, "Oh, well, my secret vault comes with a prize." And I was like, "What's the prize?" He's like, "I want dinner." And I was like, "Really? You want to play dirty now? Like, do you want me to tell everyone about your little vacation over there?"
Wait, is he coming in from like a different state?
Mm-hmm. So he's like, but then I was typing that, but I was typing like one at a time. And then his text message came through and he exposed himself. Oops. Because I wrote like the vacation destination. I was like, I wrote so he went to Hawaii.
Yeah.
I was like, wow. I wrote, wow, Hawaii question mark, right?
Yeah.
And I was typing, "You want to play dirty?" And then while I was texting the "you want to play dirty" part, he texted and he's like, "No, I was actually just thinking of asking you for dinner and a movie. But if you want to go to Hawaii, yeah, we can go." I'm like, that's not what I was trying to say. And then I saw him like he quickly responded back. He's like, "Oh, now I know what you're talking about. Oops." So I was like, "Well, you don't have a vacation property in Hawaii, so I can't go." So
You
Hawaii
guys could
is
open up
not going to
like
happen anytime soon.
yeah, but I mean, did you get your second dose yet, or when are you getting yours?
Not yet. I'm getting it. So I'll be vaccinated by the time he gets here. But he's already vaccinated.
Oh, okay.
Yeah. So that's why he's like breaking all the rules. Like he thinks he's invincible. But but yeah, it was just so funny because he goes, he was like, what did he say? He's like, "Oh yeah, so I guess I was going to," because I asked him, "So wait, are you asking me out on a date?" And I was kind of being sarcastic about it and I
Yeah.
made it a joke. And then he's like, "Well, yeah, but if you want, if you won't date me unless I have like a vacation property in Hawaii, then I guess I'm just gonna have to wait 15 years before I ask you out again." So I was like, so I didn't say anything because I was like reading it and I was like, "Oh my God, he's being really serious." And I left them unread. I was like reading, I was like, what just happened? But yeah. So then he goes, "Well, if you're okay with just a casual dinner and a movie in PJs, then it can happen sooner." And I'm like, what? So yeah, that's what happened.
When is he coming in then?
So he's coming in 3 weeks. I was actually planning on taking my boards then, but I don't know. So I was talking to him on the phone yesterday. I was like, "Look, I don't know honestly, like when I'm taking my boards and when I'm going to be authorized to take it. But if that's the weekend that I have to take it, then I don't know." And he's like, "Yeah, that's totally fine. I mean, I can like he's coming, like he had this planned out for like over
Oh,
6 months
wow.
ago."
6 months?
Yeah, like his friends and him, they apparently go snowboarding out here like every year. And
Yeah.
yeah. But I was like, "Isn't your schedule really like hard? Like I can't picture your schedule because I don't go snowboarding. I don't know how tiring it is, how far away it is. Like I don't know what your schedule is like. Like I have to think about this. I can't just like say yes, you know. He's like, it's okay, I'll make time for you. And I was like, no, like I don't want you to like change your schedule for me because I'm just a dental student. You're the one who's out here with friends from all over the country going snowboarding. He's like, I told you I would make time. Um, but that I told you part, that was I asked no, I didn't ask him. I outed him. I was like, look, you don't even have time for a girlfriend. How the hell are you going to have time to take care of a puppy? Is what I said to him because he was thinking of getting a puppy because he was so lonely.
Wow.
And then he's like, no, I would make time for a girlfriend, but not for a puppy. But I was like, so yesterday when I read that, I was like so shocked. I was like, wait, I'm so confused. How did this escalate from this to that? So yeah. But yeah, that's where we're at. This is so bad, but it all happened so fast last night. So I don't know. But putting it out there because you're like my friend now.
Hey.
But yeah. So I think he has game. I think.
Wait, sorry, your audio cut out.
Oh, I'm saying like I think he has okay game. I don't think I've ever been asked. Well, I shouldn't say never. I have been asked formally like this before, but it's been a while. Usually boys don't ask girls formally like this anymore. But it was
Yeah,
kind of nice. Yeah, it's kind of
yeah,
nice.
nice. And you can open a practice with him once you graduate.
Uh, so he's doing peds right now.
Oh, okay.
Mm-hmm.
Yeah, and you also want to go into peds.
Mm-hmm.
Yeah, see, it's perfect.
Mm, I don't know. I may be better than him.
Oh, okay.
I'm kidding. I'm kidding. I'm kidding. But yeah.
Yeah, my mom is always like suggesting at times that me or my brother should become a dentist so that we can help her run her practice.
Seriously, you guys should. But honestly, if you go into med, maybe your brother can go into dent.
Yeah,
You know?
he wants to like go into law right now though.
Oh, he does.
Yeah.
But hey, you guys are still too young. My brother wanted to go into dentistry. I didn't. I wanted to go into medicine. He wanted to go into dentistry. And look where he's at now. He's a lawyer.
Oh wow. That'll happen with my brother. Like he'll become a dentist instead of a lawyer.
So you never know. You really don't know. Because once you go to college and once you start taking some of these classes, like your eyes will open up because high school exposure to sciences, high school exposure to some of these subjects is like nothing in comparison to college. And especially if you go to like a very prestigious college, because you will be taught by the top of that particular field. And the way that they see things is totally different.
Yeah, that makes a lot of sense.
Yeah. So you'll be fine.
I hope so.
Yeah. All right, let me read out the answers. We stopped at 37, right? 37?
Yeah, this one had a lot of math.
Oh, it
Like it
did?
took forever. Yeah.
Okay. So 37 D dog, 38 C. Wait, are you there?
Yeah. Yep, I'm here.
39 C, 40 C, 41 D dog, 42 D dog, 43 A, 44 E, 45 C, 46 E, 47 D dog, 48 A, 49 B boy, 50 E, 51 D dog, 52 B boy, 53 E, 54 D dog, 55 C, 56 B boy, 57 A, 58 B boy, 59 D dog, 60 B boy, 61 A, 61 B boy, 62 A, 63 B boy, 6040 dog, 65A, 6060 dog, 67E, 68A, 69C, 70A, 71C, 72E, 73A, 74A, 75B boy.
Sorry, could you go back to 70, starting from 70?
Yes. 70A, 71C, 72E, 73A, 74A, 75B boy.
Yikes. Okay, this one was a good one.
Was it not good?
Yeah.
It's okay. This is not our exam right now, so you're fine.
Yikes. 10 wrong.
Are you kidding me? What the heck? And I thought you got really, like, you did really bad. Okay, hold on. So that's 65 over 75. Dude, that's still an 86. That's a 5. What the heck?
Yeah, no. It just because like the first 36 questions we did together. So like I'm sure I would have like
Oh.
done a couple wrong there too. So like that's a bit too close for comfort.
Mm. Okay.
Wait, are you writing on your screen right now?
No,
Okay, yeah.
not yet. Okay, can you tell me which ones you need help with?
Yeah, 38 was the first one I got wrong. I remember we did this in class, but I couldn't remember the answer.
Okay,
I
so
know
this
two,
is what it is. Do you know what a spectrophotometer is?
yeah, it's like the thingy that that like uses Beer's law and stuff, right?
Yeah. So more particles you have, less light will penetrate it and more absorption you'll have. And this is going to basically tell you how much light goes through it, how much light is being absorbed by the pigments. And based on that, you can figure out its concentration, its wavelengths, its energy, all that good stuff.
Wait, so higher concentration means more absorbance, so less light goes through.
Correct. So you need to make sure that the light that's shining, it's not going through like this. You know what I mean?
Yeah.
So you do need enough sample. So that's correct. Instrument must be periodically reset using a standard. It does, but I think we have to reset it like every time we do it. So I think, yeah, well, let's keep this. The solution must be saturated. No, solution doesn't have to be, solution can be anywhere.
Yeah.
So it's
Okay.
2, I would say.
Okay.
You always want to standardize it in between every experiment just because it's, what is it? Because of the fingerprints and just everything.
Yeah. Yeah, I remember in one of our labs, like we covered that.
Yeah. Okay. You got it?
Yep, I'm just writing that down. And you do that, you have to reset it because of like fingerprints and stuff.
You have to reset it for fingerprints, but also because it's very sensitive, this machine. So any pigment, I mean, if fingerprint is going to change the absorption rate, come on, like any drop of anything will change it.
Mhm. Is this like used in bio too for like DNA or something?
I don't know, to be honest.
Okay.
I don't think I've ever seen it being used.
Okay. Yeah, because I remember one of my friends used it for science fair.
Oh, really?
Yeah. And it doesn't have to be saturated because you're like relating absorbance to concentration. So like the concentration doesn't really matter because it's gonna have a set absorbance.
Yeah. Because the whole purpose of this is for us to figure out the concentration, not to figure out if it's saturated or not.
Okay. And then I was having trouble on 41.
Oh, was number 40 okay?
Yeah.
Okay. Strip of metallic scandium is placed in a beaker containing concentrated nitric acid. Okay. So if you have brown gas, obviously, like,
It's not hydrogen.
yeah. But obviously, there's a real chemical reaction happening. It's warm. Nitric acid is a very, very strong acid.
Yeah. So we already know that, and we don't need to like do this experiment to determine that, right?
Yeah. So I guess now all you have to do is just figure out, yeah, because nitric acid, we know it's a strong acid, so we know we're putting in a strong acid to do that. So
Mhm.
scandium nitrate is yellow and scandium chloride is, we don't know which one's which,
Mhm.
right? And plus, where's the chloride coming from?
Yeah,
Which
that's
chloride?
what I was thinking for that one.
Mhm. Nitric acid reacts with metals to form hydrogen. Um, yes and no. Hydrogen is colorless gas.
Yeah.
Yeah, we could be making hydrogen, but um, remember nitrate is a very reactive and and very soluble. It never wants to be in a solid relationship. So
Yeah.
if it pairs up with scandium, it's going to ionize,
Okay.
which means that hydrogen will still be around, like hydronium ions.
Okay.
So I highly doubt that hydronium ions will turn into hydrogen gas.
Yeah. I was thinking though that the brown gas was NO. So like if NO3 is reduced into NO, like, would that change anything?
If NO3 was changed into NO,
Yeah, because isn't NO like reddish brown? Or is that another gas?
I think, yeah, I think NO is reddish brown.
Okay.
Yeah.
But that wouldn't like change the formation of hydrogen because NO3 ionizes completely, so you would just have like H plus.
Hmm.
Okay.
So I think this is more like process of elimination, unfortunately.
Okay.
Scandium reacts with nitric acid to form a brown gas. Like that's like straight up what this, you know,
Yeah.
doing.
I thought
Scandium
that was
nitric acid, yeah, in mole proportion is a 1-2-3. You don't know if it's a 1-2-3 reaction. And then honestly, it's not a 1-2-3.
yeah. I tried writing out the chemical equation and yeah.
Yeah, it's not, oh, I wouldn't say it's a 1-2-3 just because it is, what is it? I wouldn't say it's a 1-2-3 just because just because with nitrate, like if you do scandium, that's a 2-to-1 ratio, not 1-to-3 ratio, if anything.
Wait, sorry. There's like a big thing in front of the questions. Yeah, okay, it's gone now.
Okay. Yeah, I wouldn't say it's that.
Okay. So just by like process of elimination.
Yeah, it's a 1-to it because nitric acid, it would be 1-to-2 with scandium.
Because scandium is a 2+ ion.
Yeah.
Okay.
Okay.
And then I got 45 wrong.
50 to 25. Okay, so if temperature goes down, what happens? And
They
they're
get
talking about molar mass.
Mhm.
So do you remember D equals PM over RT?
Is that density?
Yeah.
Yeah.
If temperature goes down,
Wait, molar mass is going to stay constant no matter what, even if you decrease temperature. So that's why I like eliminated 1 immediately, right?
so molecular mass. I'm thinking, yeah, if it's sealed, yeah, you're right. If it's sealed, you're right. Because you're not adding more molecules. Yeah, this would stay constant, this would stay constant. The only thing that would change would be pressure and temperature, and which will change the volume. So yeah, so that would be out. Distance between the molecules would increase, not decrease.
If you cooled, because like, don't they get closer together technically?
If this goes down, doesn't this go down?
Yeah, I think it's at a constant volume though.
Oh, shoot. Then pressure
Would
would also go down. Pressure would go down. And if pressure goes down, molecules will be further away.
Oh, okay. So, okay.
Yeah, because it's Gay-Lussac's law, right?
Yep.
Okay. And then average speed of the molecules. Average speed. If it's cool, it would slow down. So it would decrease.
Okay, so it's C.
Yeah. So this is right.
Wait.
Average
Okay.
distance between the molecules would increase, right?
Yeah, but
Okay,
like
what increase? So this is wrong. This is wrong. So only 3.
okay. The one thing I was like sort of confused about though, like when you cool like a gas down, it like eventually forms liquid, right?
Yeah.
Which means that like the molecules are closer to each other.
Yeah. But it's
So,
no longer gas phase, so it's no longer ideal gas then.
oh, oh, ideal. Oh,
Yeah,
okay.
because by definition, ideal gases, they have to be so far away from each other that there's no attraction.
Okay.
This one was hard.
Yeah.
This one was hard.
Wait. So that isn't like an ideal gas at like high temperatures and low pressures.
Yeah.
So in order to do that, would you need like a change in volume since like technically pressure when you increase temperature you also increase
Yeah.
pressure. So okay, you would have to like play with the volume to keep
Yeah.
like pressure low. Okay. Okay. 47 I was also a bit confused on.
7. Which of the follows the lowest conductivity? If it has the lowest conductivity, it means that it's going to be the least ionizing compound,
Okay. Is
the most insoluble one.
okay. So copper sulfate is soluble.
Copper sulfate, it should be insoluble, but if you put it in water, sulfate is a very strong acid, so it will become soluble.
Okay.
I would say D, just because HF by nature doesn't like to ionize.
Yeah.
But yeah, I see where you are coming from. But
Yeah.
my thought process says if you put it in water, because obviously you would only conduct electricity in water,
Hmm.
H2SO4 is a very strong acid.
Right. Right. So H would replace Cu, right?
Yeah,
Since yeah, because of the activity series thing.
yeah.
Okay. Um, 51. I then got wrong.
51.
Yeah. I think I overthought this one.
Okay, so okay, yeah. This one, all you gotta do is look at the ratios. HCl
Yeah.
must be less than Cl2. I think you have to be larger, right? Because usually when you go to the right,
Hmm.
so like wait, for HCl plus O2. So if you have 4, let's just say that we have all 4s, right? But if this is at equilibrium, you don't necessarily have to have 2. It'll look something like that, right?
Yeah.
So if you have equal moles of HCl and O2 in a closed container, they reach equilibrium. HCl must be less than Cl2. No.
No.
O2 must be greater than.
But yeah. Okay. Okay. Yeah. Because HCl is the limiting reactant in that case, right?
Yeah, yeah. And then Cl2 must equal H2O. Cl2 and H2O must equal each other.
Okay. That makes sense.
Yeah.
And I got 52 wrong.
52.
Hmm.
When dilute acid. um, So calcium hydroxide, do you know, like, you know how sometimes when you go to like old bathrooms or something like that, there's like a calciumy ring around
Yeah.
faucets?
Yeah.
Yeah, that's the white precipitate that they're talking about. You can actually get rid of that with baking soda
Hmm.
because do you see, you know that Na is just going to like ionize. But do you remember how this turns into H2O plus CO2?
Yeah.
And so CO2 will just evaporate out, and then you'll be down with just water and calcium.
Oh. Oh. Okay.
This is a very common question that they love to ask.
Okay. Yeah. I put baking soda at first, but I thought it made hydrogen gas, not CO2. So I didn't know how the precipitate would form. Okay, and then the precipitate would be CaCO3.
CaCO3, yeah.
Okay.
But
So,
the CaCO3 would ionize, and then you would have carbon dioxide bubbles.
oh, okay. So even that would like break down.
And honestly, calcium hydroxide, when it's dry, yes, it turns into white precipitate. But if you add water to it, it's a pretty, basic thing.
Yeah.
It will ionize.
Okay.
It's just that the lime water part, a lot of times you do end up with the white precipitate around the faucets and stuff because there's more than just calcium hydroxide there. There's like other minerals, you know what I mean? That kind of like keeps it there. Oh my god, I was just thinking of plaque. I need to get it out of my head. Yeah.
Yeah, that happens around our faucets.
Yeah. Yep. Yeah, this past week has been crazy. It's been super, super crazy. Oh, I'm done with all my didactics. I am done with school exams forever and ever.
Oh, so you passed that one exam.
I did. I passed all of my exams. I'm done.
Yay.
Now all I have to do is just take boards. God.
Then
My
what do you
favorite.
do in your fourth year?
What?
What do you do in your fourth year then? Just apply to residency?
So yeah, so fourth year we have the practical, we have the licensing exam.
Oh, so you're just like studying for that.
Yeah, so we have like the patient portion where we have to take the exam on a real patient. But this past year, because of COVID, they transitioned it over to mannequin. And because, some states, like because of COVID, you're not supposed to have like a certain number of patients in a clinic.
Yeah.
And because of that, they've transitioned it to mannequin. But it seems like it went well this year, and people were talking about how it's unethical for us to be taking our licensure exam on real patients, blah, blah, blah. And because in medical school, you take your licensure exam on mannequins, you don't do it on real patients anymore.
Yeah. I think that kind of makes sense because like if you mess up, that could have like huge consequences for a human.
Yeah. But I mean, yeah. But so then for medical school, they were talking about that. And so they were like, oh, dental school is so far behind. Like you guys should also like change it. So they were talking about it. And then this year, because of COVID, they had to implement it. I think it went well. So hopefully next year we have that option too.
Mhm.
Um, so I would just have to take the mannequin test. Because the other thing is this sometimes some of these patients are very unreliable. So I remember when my dad was taking his exam, like he had to pay his patient. I think he paid like $500, and this was like gazillion years ago.
Oh wait, your dad was a dentist too?
He was a doctor.
Oh, okay.
Yeah. So I remember like he had to pay like $500 for the patient to actually show up, and he had like two patients, just in case like one didn't show up or whatever, or like if they showed up and they still like did not qualify, then
Yeah.
have another patient. Um,
Yeah.
so that's still a lot of money for a student to pay, right? And I
Yeah.
my upperclassmen, they were paying like 300, 500. Some of them were paying $700 for their patients to make sure that they were coming in.
Wow.
You like treat them to breakfast, lunch, and dinner, and you treat them like royalty. And it's like, dude, like seriously?
They're getting like free dental work and money. Like,
For
wow.
sure. For sure. So then people were saying, oh, it's so unethical. And then like students are going to have a really hard time. Like, what the hell? Why are you doing this? Why are you doing that? And so then, yeah, I don't know. Hopefully, I don't have to take it on a real patient. I mean, I have enough patients to go around the block, but yeah.
What if the patient like doesn't need dental work too? Like then
So we screen the patients. We screen the patients prior to our exam, like a month or so before our exam, we screen them. and we build that rapport with them. So for instance, like one of the exams is a cleaning, but you only do one quad, so like 1/4 of the mouth. So
Yeah.
all the other quads, we just do free cleanings for them prior to the exam so that you can build that rapport with the patient and just say,
Mhm.
hey, this is basically what I'm going to be doing on the exam. Like I want to see if you are okay, blah, blah, blah. And then also like you have to get used to the patient's mouth,
Yeah.
which yes, it sounds very unethical, but I mean, how else are you supposed to take these exams? Like you're going to be going and treating real patients, you know? Like, I don't know.
Yeah.
It's so funny.
So
Yeah.
like,
Also talking about, sorry.
no, 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 go ahead. Sorry.
They were also talking about injections and how we are no longer going to be stabbing each other. So that's
Yeah.
you're going to do too, because I know in medical school you stab each other to draw blood. Obviously, like as doctors, you never have to do that
Yeah.
because your nurses will be doing that for you. But you still have to know how to draw blood, right?
Mhm.
So you stab each other to do that, but apparently they're no longer going to have us do that. They were like, oh, it's unethical to stab each other. So then one of my D4s was like, so it's more ethical to stab for the first time on a real patient. Yeah, apparently it is.
Wait, so you guys would like give each other like the mouth numbing injections?
Yes.
Wow.
Yes. And that's so funny because I was talking to the boy yesterday and I was telling him, yeah, so we were stabbing each other, but I never stabbed like local infiltration, like the smallest injections. I never learned how to do that. I
Yeah.
only learned how to do like the big injections. So I didn't know how to do it. And then the faculty was like, Vicky, you don't have to give them a block. So a block is basically you numb them completely.
Yeah.
And this was a very small procedure. So the doctor was like, "Oh, you don't have to numb them completely. You just have to numb like just a tooth." And I was like, "I
Yeah.
don't know how to do that." So then the way he explained it was, "Vicky, all you have to do." This sounds really unethical, but really it's actually not as bad as it sounds, okay? He said, "Just poke." He said, "Just poke and let it inflate." And I was like, poke where and how much? But obviously, like, so I was telling the boy this yesterday. He started laughing his head off and he's like, I can't believe you didn't know how to like do local infiltration. I was like, well, I know how to do blocks, but I don't know how to do like the simple ones. Like, what the hell? Like, they never taught us that. So then he's like, oh, do you know how to do this block or that block or that block? And I was like, yeah, I know how to do it. But there's one block that goes all the way up to here, like your eyeballs,
Wait, what?
right underneath your eyeballs, like literally. You go up through here and then you inject it right there. And you literally just like all this gets numb, like nose all the way to your front teeth, all that gets numb. And you're blocked for like 3 to 4 hours. And that's actually not part of our, I guess, um, required injections to learn.
Yeah.
You learn it when you're like in specialty and stuff because there's not a lot of times where you actually have to completely block like the whole nose part.
Yeah.
But I ended up doing it because my stupid partner, he was supposed to just go up on me like this much and
Yeah.
inject, but he kept going and I was like, ow, and he kept going. I was like, Ayrton, ow. He's like, wait, I just want to feel what it, I just want to know what it feels like to like do a block. I was like, so I told him about this and he started laughing. He's like, oh my God, so you learned how to do an IO. And I was like, yeah, I learned how to do an IO the hard way. He's like, good, because you're going to have to do them when you're in PEDS. And I was like, what do you mean? We have to do an IO on babies? He's like, yeah. Apparently he never learned. So when
Yeah.
he started residency, one of the doctors was like, yeah, just do an IO, like you'll be fine. Like the baby's crying and the baby's 1 years old. And I'm just like, you gave the baby that's 1 years old an injection that goes all the way to his eyeballs.
That sounds so like cruel.
Right? I was like, what the hell? He's like, yeah, I was so nervous. It was my first time doing that vlog. And, like the baby is crying, and the baby can't tell me if it's pain or pressure. And the baby's just crying because he's like away from his mom. So he's like, I don't even know if the baby was numb, to be honest. And I was like, oh, I didn't even think about that.
Why would a baby like 1 year old need dental work though?
So, unfortunately, there's a lot of mothers who are not very well aware
Yeah.
or educated. There's a lot of lack of access to education, unfortunately. And this baby came in 1 years old, barely had teeth here in the front, but
Yeah.
so infected that his whole face was like inflamed, like this.
Yikes.
So then he was trying to do an injection on the baby, but if you are inflamed and you have an infection, injections don't really work.
Yeah.
So, yeah. So you have to give them a block. And he was like, yeah, I was so nervous. I felt so bad. It was horrible. And he was like, you're going to have to go through that. I was like, no, I'm not. I am not doing that. But yeah. Yeah. And that's sad. I never thought about it.
Yeah, neither did I.
I never realized that, oh, you're right. Babies can't talk. They can't tell you if they're numb or not.
Yeah.
Shoot. Something to think about. Like, they're crying, yeah. For what though? Because they're hungry, or because they're away from their mom, or because they actually hurt?
Yeah.
Yeah, I guess you don't think about these things. It's kind
Yeah.
of interesting.
Yeah. And I feel like the experience would just sort of like make them scared of like ever.
Yeah, it's traumatizing. Thank goodness that he's only 1 years old and he probably doesn't remember it, but I'm sure somewhere in the back of his mind, psychologically, may have like traumatized him somehow. Um,
Yeah.
yeah. I hope it's not a lasting trauma. Shit.
Yeah.
I don't know. It was just interesting to hear that side of the story. I'm like, oh, I never really crossed my mind.
Yeah.
Yep.
Well, hopefully you
You'll be
won't
there.
have to go through that.
You will be there soon. I don't know if med school students are still drawing blood on each other. I know my friend did. She's a third year in med school.
Oh wow.
Yeah, she's a third year in med school. She's at Rutgers, so they did it, but I don't know if they're still doing it for the first years. I will see.
Yeah, I know in AP Bio we test our own blood types. So I guess it's not the same as drawing blood, but it's still like blood.
No, these syringes are huge. They're like this big.
Yeah, it's like are they the ones that you like that are at the blood test places? Like when you go to get
Oh
like
yeah, yeah,
yeah.
yeah. And then have you ever, oh, maybe you're too young to do this, but I've donated blood in the past and the syringes, the gauge is like, it's like this big. I'm like, how much blood are you trying to take from me? Run me dry here? Yeah. But apparently I don't have enough blood to donate anymore, so I can't donate.
Oh, yikes.
Yeah. Like there's like a weight requirement, and then there's like a hemoglobin requirement,
Yeah.
and I don't pass either one.
Yeah. I can't do it yet, but as soon as I turn 16, I passed the weight requirement barely.
Oh.
But yeah.
Yeah, I donated when I was 16. I was chubby enough to do that. But I think in college I was trying to do it. but I didn't have enough hemoglobin or hematocrit for that matter. And so they were like, oh no, you can't do it. And then I tried to do it again when I was an adult. And then they told me, no, you don't meet the weight requirements. You can't. And the funny thing is, they went from 110 pounds to 120 pounds. So now, because I was like 107, so I lied. I was like, I'm 110. And they're like, yeah, your hematocrit is so low, you can't do it. I'm like, shit. And then now it's like 120 pounds. And then they look at me, you're like, there's no way you can be 120 pounds. I'm like, okay, thanks. Yeah, it's just liability, and that's why they do that.
Yeah.
But honestly, some of my friends actually, like one of my friends is blood type O, and he was working at a lab. This like during his pre-med like years, he was
Yeah.
working at a lab, which you probably have to do too. When you go to college, you want to work in a lab.
Yeah.
Working in a lab, and this was about like blood testing stuff, right? And my friend is blood type O. So they were drawing blood from him literally every other day. And my friend was like, this is so unethical. You have to wait at least 2 weeks for my blood count to go back up to draw blood again. But he was like, anything for medical school. But yeah.
Wow, that's dedication.
Seriously. But now he's a faculty at Yale, so I guess it all makes up for it.
Out.
It all makes up for it. Yeah. Anyways. Okay, what's the next one?
63. This was like a very math intensive one, so I probably messed up somewhere there.
Okay, so if it's 16 hours,
That's 3,600 seconds per hour. And then you have 3 amps.
here's the other thing. Back in the day, they used to round it up to 96,500, but it's now 45. Oh no, we're not doing electrons.
Yeah, it's the other way around, right? CuCl2. Oh, so I have to take into account that it's CuCl2.
Yeah.
Wow, okay.
See,
Okay,
I see the answer.
yeah. Hmm. Wait, so would it be E then?
B boy or E elephant?
E elephant?
I don't think so. How much did you get for CuCl2?
I got 134.5 grams.
134?
Yeah, 134.5. So like 135. You have to multiply by 2 electrons though on the denominator, right? Because you need.
Oh wait, hold on. Yeah, hold on. I think, so that's 1 mole of electron, 2 moles electron, 1 mole CuCl2, 1 mole CuCl2, that's 134.5 grams.
For the coulombs, I got
I
172,800
got 120.
for coulombs.
No, I got E as well, but the answer is not E.
Yeah, I think they're asking about copper only though, right?
I think
No.
so too, not the whole thing. But it's still 2 moles of electrons. Copper is what, 30? No, 60? No, forget what copper.
63.5.
Huh?
63.5.
Let's see. I got 56.
Okay, so I just did my math poorly.
Yeah, so the answer does say it's B. I think we just misread the part that they were asking for copper and not copper chloride.
Yeah, I did copper. What did you get for the number of coulombs though?
What do you mean?
I'm just trying to figure out like where I made my mistake. Like for the part before like the first
Like
three,
here?
the one right before that, yeah. Yeah, there for that one. Sorry.
For this?
Yep.
Hold on. I just plugged everything in. So
Oh, okay.
I did 96485 and I got 1.79.
Oh. Oh, okay. I thought that was like 2. Okay, yeah, that makes sense. I think I just did math poorly. Okay. And then the next one I got wrong was 64, but I know where I made my mistake. I only doubled the mass when I should have quadrupled it because it's like square root, right?
Oh yeah, yeah. Square root of the inverse of the molar masses.
Yeah. So would it be? But there's nothing that's like 17 times 4 mol right?
If it's 1/2 that rate, it should be 0.1 moles per minute, right?
Shouldn't it be 0.0025 moles per minute?
So you're saying it's going to travel faster?
Yeah, wouldn't that be slower if you're using less moles in a minute?
Because it's only fusing half of that rate.
Yeah.
It'd be slower. It would be slower because it's heavier.
Mhm.
Heavier over 17.
Oh, would I have to like solve?
I don't 2.5 per.
No, wait, wouldn't it just be the ratio of like, wouldn't it just be 2 equals that, not 0.025?
That's what I thought. It would be just 2 times, right?
Yeah,
Okay, so then 2 squared, 17, I guess 68.
okay, I understand now. So it would be D.
Yeah, that's the closest one.
Yeah, I
Yep,
think I
the
need
answer
more.
is D. The answer is D.
Yeah, I need to work on my multiplication skills.
I need to learn how to read.
That
Okay.
67 I got wrong then.
Okay.
Wait,
Fractional
wait,
crystal. Oh, sorry. Go ahead.
could we, I just wanted to check something for 65. Barium sulfate would be least soluble in A because of the common ion effect, right? Just because you have
Correct.
sulfate ions.
Yeah.
Okay,
And it's got the largest number of that common ion.
okay.
Yeah.
Okay, yeah.
And plus, do you see like ammonium and sodium? These are always soluble.
Yeah.
You said 67?
Yep.
Yeah, 67 fractional crystallization. That just means anything that is fractional, it has to do with density or it has to do with boiling or freezing point. Um, what they do is they are fractional crystallization. Here, let me show you a picture. So fractional crystallization is supposed to be like difference in boiling point or freezing point.
Hmm. Wait, isn't distillation difference in boiling point?
It is, but if it's fractional, um, can you see this?
Not the entire thing. Okay, yep, I see it now.
Okay. I'm assuming you got that. Wait, I'll just put it here and then we'll remove it.
Yeah, that's fine.
So we have difference in boiling point, yes, but it's going to be a bit more like, I guess, more accurate
Hmm.
because it goes through this colloid thingy. Hold on, let me see if
Okay.
there's a thingy of that. Yeah, because it's a colloid, and yeah, I guess you have to figure out its. I thought fractional crystallization was just for phase changes, but I guess. Hold on, let me check. Yeah, you have to heat the solvent, mix it, gradually cool it down, and then figure out its components that crystallize. Um, but it is based on, okay, now I get it. So it's based on their solubility because you're boiling, whichever one is dissolvable or soluble will evaporate out and go through the condenser. And then through the condenser, it'll come out, but it'll come out as a solid.
Okay.
So they only dissolve at higher temperatures.
So wait. So you have like a sample of like you have a thing with like a solution of two different things, and then you boil it, and then the one that's more soluble would boil off.
Yeah,
Wouldn't it be the one that's less soluble? Why would the more soluble one boil off?
because the more soluble one can turn into gas faster.
Wait, but doesn't it have to like break the IMF of like water attractions and stuff? So wouldn't it like take more for it?
So the more soluble one wouldn't. So my understanding is it's difference in crystallization. So it's difference in melting points. So you dissolve. you increase temperature. When you increase temperature, whichever one dissolves will evaporate and get caught on the, so it's kind of like, I think it's like this. I'm not 100% sure either, but think of it as this. Like you will end up with crystals down here, and then whatever evaporated, it'll end up as liquid.
Okay, wait. So you have like crystals, and
So
then
think of it as like wine. And when you start evaporating wine, at the very bottom of the wine, you'll have like pieces of like grape, I'm assuming.
wait, but isn't that distillation?
I thought distillation was just difference in boiling point. They're
Yeah,
both
that's
liquids.
what I thought too.
Hold on. Wikipedia says, Wikipedia. If a mixture of two or more substances in solution are allowed to crystallize, for example, allowing the temperature of the solution to decrease or increase, the precipitate will contain more of the least soluble substance. The portion of the components in the precipitate will depend on the solubility products. If the solubility products are very similar, a cascade process will be needed to effectuate a complete separation. This technique is often used in chemical engineering, obviously, and therefore I have never used it. Let me see. So I don't know what they mean. I don't know which one is the more soluble and least soluble.
Wait, okay. So, but in general, if something is more soluble, it will boil off first.
Yeah.
Okay.
Yeah, in general, if it's, hold on, there is a YouTube video. Oh, look, there's a fractional distillation. I just want to switch. Can you see this?
Yep.
Oh, that's a pretty blue. Okay, so can you kind of hear this too?
Yeah.
Stand, otherwise it will fall over. Got a
Can you hear
green
it?
rubber gasket to make a seal between the Erlenmeyer and the Buchner. We'll take our pre-weighed filter paper and make sure it sits flat, not crinkled or puckered, or solids will get under it. We'll seat that paper with a bit of water. Whenever you pour solids onto a Buchner funnel, pour them quickly as you can without spilling it, so that you cover the entire surface of the filter paper. You don't want a clump in the middle. You want it evenly spread over the surface. And similarly, when you wash that precipitate, spread water over the entire surface. Don't spray it on. This is the way it's done industrially. It's called plug flow on vacuum filtration systems. Notice I'm going to take the lid off the wash bottle. Don't spray it, rather pour it over the entire surface. It's the best way to clean a precipitate. Just wanted you to quantitatively set it through a beaker and boil it down on a hot plate to about 15 milliliters. Get rid of the bulk of the water. Mass or less. CSP has solution, otherwise we won't be able to impurities before vacuum filtration. Here it's been sitting in the ice bath for 10 minutes, and now our final step is vacuum filtration. Once again, try and get the solids evenly distributed over the entire surface of the filter paper. Don't make a cone in the center. And likewise with the wash, spread the wash evenly over the entire surface.
So I think that's all they're doing.
Oh,
Literally,
okay.
that's it.
So like the basis of this is like more soluble objects boil off first. So they'll be the ones to like
You filter it out.
yeah,
You
they'll
left
be
with
like
the
the ones
precipitate.
okay. So they'll be the
Yeah.
okay. So okay.
I was kind of that. I don't know why that was. I don't know why they're drawing it like this then.
I think that's distillation.
I think so too.
Yeah, it says so at the bottom as well.
Yeah. I guess now we know fractional distillation.
Okay, so in crystallization, so the more soluble objects are boiled off first, so they're filtered out and they leave the less soluble objects.
Right, as precipitate.
Oh, that makes sense. Okay. There's like the less soluble objects have like more attractions with each other, so they'll be like harder. Okay. Yep. 71 then I was confused on.
Here I thought you were done with 71 and I put the picture over 71.
No, I got a lot wrong at the end. I tried to do redox balancing, but it didn't work out.
I don't think this is redox.
Because it says oxidizes FeOH2.
I don't think this is redox. That's 4 iron, 4, 8. That's 8 oxygen plus 2 plus 1. 11. That's 12.
H2O.
That's 12 hydrogens. 10.
Is this really just balancing?
I'm like, huh, if Ritvik got it wrong, this must be a very hard question.
No. 73 then I got wrong.
Oh, Ritvik. Here I am thinking.
I was like so
hard. So you end up with 0.3. That means you add 0.3.
And subtract 0.15. Oh, I forgot to square the coefficients. Oh my god. Okay. I understand why I got it wrong.
I don't know if I like you anymore.
Okay, well that will not happen again.
That's fine. I think at the end, I think think towards the end you were just thinking like, oh, these are like the last questions, they're going to be hard?
Yeah, I think I was like also a bit pressed for time because I was like trying to do it all within like an hour and a half, the ones I had left.
Yeah, it's a lot of questions. Did you get
And
74, 75 okay?
75, I got wrong. I didn't, I was confused about it. I didn't know what it meant by direct current power supply, like in terms of like voltaic or like electrolytic cells.
I don't think you have to worry about this. This is like AC versus DC stuff. Um, so either way, if there's a power supply, it would be electrolytic. It wouldn't be galvanic. So the polarities of the power supply would be the cathode would be negative, right? And the anode would be positive. Cathode undergoes reduction, so you're gaining electrons.
Oh, so would it be A because you would turn I into I2?
Uh,
Because positive and you're oxidizing I. So would 75 be A?
so no.
Okay.
Right, because it'll be PT and then I minus I2.
Wait,
Why would it be I2? Wouldn't it be?
I was thinking that in the electrolytic cell, like now I'm thinking that you would be
Is
reducing.
platinum PD? That's palladium.
Is it platinum or?
I don't know. It says platinum. I don't remember if platinum was PD or PT. I don't think it matters.
I think it's PT.
I think so too. I think
Yeah.
PD is palladium. Okay, but either way, we're dipping it in Ki
Yeah.
solution.
So in an electrolytic cell, don't the electrodes not like participate in the reaction? They're just sort of there to uh
Which
almost
one doesn't participate in the reaction?
the electrodes and some electrolytic cells.
What do you mean?
Like so basically you have like the solution and then you have the electrodes. And then like the the cation is reduced and the anion is oxidized to make the
Yeah.
elemental substances. But I could be totally wrong.
Gas will be bought at the positive electrode. So it would be I2. I2 will be the gas.
Yeah.
So it goes from negative to 0. So that means you have to add 2 electrons on this side. So this one is oxidizing. So if it's oxidizing, it would have to go into the oxidizing. It would have to go to the anode.
The answer was B, right?
Yeah. If you're losing electrons, it's oxidizing.
Mhm.
I thought this was. It's. Let's see. So K plus ions are attracted. Okay.
Oh, the gas is hydrogen.
This is a little bit harder than what I've anticipated. They're saying that K plus ions are attracted to the negative electrons, which makes sense.
Yeah, so they're attracted. Okay. Yep.
This is attracted to this, the cathode, because it has to undergo reduction.
Mhm.
But all this is in water because it's
Yeah.
a solution. And
Yep.
H2O is easier to reduce than potassium.
Mhm.
So because of that, you don't really reduce potassium, you reduce water, which still makes no sense, but whatever. So
Oh, I2 is this. Okay, sorry. I2 is a solid, right? So you wouldn't have a gas.
yes, so you end up with H2 gas plus OH minus. That's what you get. That's what they're saying. This is hard.
Yeah.
This is really hard.
Yeah, I agree.
Well, now you know.
Yep.
Now you know.
Wait, so it's H2 gas plus O2 minus?
OH minus.
Oh, OH minus. Okay. Okay.
All right, Ritvik. Do you mind if did you ever finish 2013 or were you going to like
No, I wasn't able to finish that.
okay, let me put up another MCQ on our Google Drive. And then we'll go from there next class. When is
Okay.
your Olympiad?
Yeah, sorry.
When is your Olympiad?
It's on March 27th.
Okay, so we still have a little bit of time. So I guess
Yeah.
next class we will prioritize the Olympiad. Try doing one more.
Yeah, I'll probably do like a couple more. So
Okay, so let's go over the Olympiads. How are you doing with organic chem? You good?
yeah, I've been like scoring like consistently recently. I've been scoring like 54, 55, but I think the organic like I make a couple of mistakes here and there, and then the organic chem is like really dragging me down.
Okay. So why don't we do this? Let's prioritize Olympiad next class. I'll put up finish 2013. And I'll try to put up another MCQ so that you can do some of those.
Yeah.
And we'll go from there.
Okay, sounds
Okay. Sounds good.
all right.
I'll see you next week.
Yep. Bye.
All right, bye.